Good evening, good afternoon, good morning to everyone. So we continue with our lesson on probability, the basic rules in probability, and I believe that we have a clear understanding on some of the basic rules, where we talked about the additional principle, and we also talked about the complement rule, as well as we talked about the multiplication rule. So today I want us to focus on the conditional probability, where we'll be able to look at what conditional probability is, and we can also dive into a number of examples concerning conditional probability. Now I want just a recap concerning multiplication probability, the multiplication rule in probability. Remember, I'm sure you can recall, under the multiplication probability, when we're talking about two cases, talking about the multiplication rule, where we considered about two cases. The first case, it was in a situation where we simply said that two events should be independent. So when it comes to cases where we're being told that these events are independent, we are having the rule which simply says that these events can occur, or we are able to find the probability of us getting event A and event B at the same time. So under independent event, we're being told to the probability of getting A and B is just basically equal to probability of A multiplied by probability of B. That's in the case when two events are independent. So in the category of independent events, I'm sure you can recall, we simply said that two events can only be independent provided that their probability does not affect the occurrence of the other. So in this case, if A and B are independent, it means that the occurrence of A does not affect the occurrence of B. So these two probabilities are not affecting the other. But when it comes to dependent events, this is in a situation whereby the probability of getting A has already affected the probability of getting B. So now we can give it in an example where we're talking about maybe certain colors of balls in a bag, like the way we did with last time when we talked about, I think, a red card being drawn from a bag. When we're talking about multiplication rule, we're talking about drawing the first red card without replacement. Then we're talking about these two events can be considered to be dependent events. So now, collecting a red card in the first collection, the probability cannot be the same as collecting the red card in the second collection, because that card was not replaced. So when it comes to the dependent probability, this is where the conditional probability is being drawn from. What is dependent event? In this case, the dependent event, we're being told that the probability of A and B can be found by simply saying that probability of A multiplied by probability of B, given that A has already occurred. So now this is the first collection of, maybe let's say, picking my card which contains A, and in the second collection I'm trying to pick my second card, maybe it can be B card. So now, what is the probability of picking an A and B, provided that A and B are dependent events? It means that the occurrence of A is affecting the probability of B. So in this case, I'm collecting A in the first place, and what is the probability of collecting B in the second place? In this case, we are simply saying that the probability of me collecting B, we're trying to emphasize that given that A has already occurred. But when it came to independent events, this is a situation whereby if I'm talking about maybe cards, these are two cards. probability of A and probability of B are independent in such a way that the probabilities are not affected in both cases. The probability of picking an A in the first place is the same probability of picking an A in the second place. So the probability of maybe picking B in the first collection is the same probability of picking B in the second collection. Unlike of those dependent events, where we're simply saying the probability of picking an A has already affected the probability of being picking a B. So this is under two cases of events which we're talking about. Yeah. So now connecting to conditional probability, just as we are talking about dependent events, under dependent events, we simply say the probability of A and B should be equal to the probability of A multiplied by the probability of B given that A has occurred. So this guy is the one which we're talking about, the conditional probability you're trying to look at there. So what are we talking about under conditional probability? We're being told that if we want to find, so if we're simply saying if the probability if we want to find the probability of event B given that A has already happened, so how do we find that probability? So this is just as good as saying making this guy the subject from the concept of multiplication principle. So if you want to make this guy a subject, when we're talking about the probability of B given A, what formula do we have? So this is just basically denoted as the probability of B given A to be equal to probability of A and B over probability of A. So the conditional principle in this case under probabilities, we are being told to say if we want to find the probability of event B given that A has already happened, therefore this is just as good as probability of B given A is equal to probability of A and B over probability of A. What is the probability of A and B? The probability of A and B is just basically the intersection maybe if I was to say so. So now look at this. Or maybe if I was to represent it in a sketch way, I can say this is event A and this is event B. So what are we simply saying? This is maybe the probability of me picking A and this is the probability of me picking B. So what are we looking for? We are looking for the probability of B given A has already occurred. So what is the probability of A? The probability of A is this. This A has already occurred. This A has already occurred. But in the occurrence of A, we want to find what is the probability of us picking a B. So the probability of us picking a B when A has already occurred, that is how we're trying to insist that this is just basically the probability of A and B, meaning that this is just the probability of A intersection B over the probability of A. So the only way I can get my B from the probability of A, it is this part. So this part, it is the only thing which is going to give me my B. So what are we simply saying? If you want to get the probability of B, given A has occurred, it is this part over the total probability of A. Meaning, I'm going to have the intersection of B, the probability of A intersection B, divided the probability of the total A. With that case, I'm going to consider, or maybe I'm going to come up with my what? The conditional rule in terms of probabilities. Now, look at this example which is given to us. I want us to look at this example where we'll be looking at the conditional probability itself. in this form of a question. For example, I've been told that if a bag contains 3 red and 5 blue balls, and we pick one red first. So we pick one red first. So in our first picking, we're going to pick one red first without replacement. And then we have 3 questions which I want us to focus on. These 3 questions are: number 1, what is the probability that the second ball is red? Number 2, what is the probability that the second ball is blue? And number 3, what is the probability that both balls are red? So, answering this question, number 1, try to understand how are these 2 events, how are the events related? Remember, events can be independent or events can be dependent. So in a situation whereby I'm picking something without replacement, it means that the first event and the second event are basically dependent events because there is without replacement, and because it is not replaced, there are changes in probability. So because there is without replacement here, it means that there are changes in probability. So if there are changes in probability, it means that the probabilities have been affected. And if the probabilities have been affected, it means that these kind of events are basically dependent events. So it means that the selection of one red in the first place and the selection of another red in the second place, these 2 basically are dependent events. So if you are talking about dependent events, it means that we are trying to go and connect to conditional probabilities, where we are simply saying that if I'm looking at the probability of me picking my second red, remember we are picking a second red this time around because the first red was picked already. So now the first red was not replaced. It means that it has affected our second picking red. It has affected our probability in picking the second red. So for me to pick my second red, it is a conditional probability. I'm simply going to say probability of red 2 given that red 1 has occurred will just be basically be equal to what is the total number of red am I going to have in the second collection. So remember, we have how many reds? 3 reds and 5 blue balls. So in total, in the first picking, so in short, if I was to look at my picking of the probability of the red 1, probability of picking red 1 will just be basically equal to favorable outcome, which is a 3, over the total, which is a 8. So this is the probability of me picking the first red. But the question comes in to say, what is the probability of me picking the second red? Now, the probability of me picking this second red will not be the same probability as in the first place, but it has been affected because the first red was not replaced. So this time around, I'm going to have 2 over the total 7. This will be my probability of picking my second red. Now, let's say in the second situation, in this case, where we're being told to say, what is the probability that the second ball is blue? Now, assuming that it was not red, we want to find the probability that it was a blue ball. So the second ball was blue. So for me to pick the second ball to be blue, I am being given that in the first scenario, I picked a red. So in this case, this is still a conditional probability where we are trying to look at the probability of picking a blue ball given that the first one was red. So this time around, I'm focusing on my blues. How many blues am I having this time around? I'm going to have 5 blue balls because in the first picking, I only collected a red ball. So it means that the total number has been affected. It is no longer total 8, but it is now a total of 7. The only thing which has been affected, it is the red balls and not the blue balls. The blue balls are still intact. So the blue balls are still intact. So in this case, I'm going to have the probability of picking my second blue ball to be blue to be 5 over 7. But if it was the second ball, if it was red, the probability could have been 2/7, because we're simply saying that in the first place we picked a red ball. So now these events are dependent events, where we're simply saying that these probabilities are affected by each other. If the probability were independent events, the probabilities could have not been affecting each other. They're affecting each other because the events are dependent. If they were not affecting each other, then the events could have been independent, such that the probability of picking the second red ball could have still be the same as 3/8, because the red picked at the first time would have been replaced. So if the red was replaced, it means that we're now dealing with independent events. But if the red is not replaced, it was dealing with dependent events. Now, what is C saying? C is trying to instruct us that what is the probability that both balls are red. Now, the key word which we're talking about here is both balls being red. So it means that what is the probability that in the first picking we picked the first red ball, and in the second picking we picked the second red ball? What is the probability of that? So in this case, we're looking at C, where we're being told to look for the probability of the first picking. It is a red one, which is the first ball, it is red, and the second ball again should be red. What kind of rule are we using here? This is an AND. We're talking about picking one red in the first picking and picking another red in the second picking. So this kind of event is being we are having the kind of rule called the multiplication principle, where we're simply talking about multiplying the first probability times the other probability. So now, if these two are following a multiplication principle, what I'm trying to say, we're simply saying that probability of red, which is the first ball, in the first place we picked a red, multiplied by the probability that in the second place we picked a red ball as well. But remember, how did we pick a red ball this time around? It was given that the red one has already been picked. So we have two probabilities here which are going to be found by the multiplication principle. Probability of picking the first red ball and probability of picking the second red ball. So how am I going to find this? This is just as good as me multiplying 3/8 multiplied by 2/7. Just like the previous examples we've been looking at under multiplication rule. So probability of red 1, which is equal to 3/8 multiplied by probability of red 2, which is 2/7. So we can do the multiplication there, and we have the probability that the first was red and the second was red as well. So we are using the principle here, which is the conditional probability, emphasizing that, in short, what we're trying to say here is that the conditional probability is also coming from the multiplication principle again, but trying to emphasize that these events are dependent events and not independent events. So we'll look at more examples under conditional probability so that we can be able to understand fully under this topic. Let's look at another example where we are being told that a fruit basket contains 25 fruits, of which 20 are apples and the rest are oranges. Of which 20 are apples and the rest are oranges. So if the two fruits are randomly picked in a sequence without replacement, what is the probability that both fruits are apples? So with the understanding of this question and the understanding of conditional probability, as well as the understanding of dependent events, you can still try by pausing the video and try to solve it through. Then you can later on play and compare your solution with ours. So what are we simply saying here? Number one, we're being told that this is a fruit basket containing only two kinds of fruits: apples or oranges. It means that if someone was to pick a certain fruit at random in a basket, there's a possibility that it's going to come up with an apple, or there's a possibility that it's going to come up with oranges. Remember, probability is just about talking about chances. What is the likelihood? What is the chance that this person is going to come out with an apple? Or what is the chance this person is going to come out with an orange? That's what probability talks about. So now this question is emphasizing what is the probability that both fruits are apples. So number one, we're talking about the concept of us having both. So in the first picking, it was an apple, and in the second picking, it was an apple. So what kind of rule emphasizes on both? The kind of which emphasizes on both picking the same kind of thing, it is the multiplication rule, where we're talking about the probability of event A and event B happening. So event A happened in the first place, and event B happened in the second place, of which for us to find the probability of A and B happening, it is just basically coming up with a multiplication principle. So the concept of both here is simply bringing us to attention that we are supposed to use a multiplication principle in this case. So what are we simply saying? We are finding the probability of picking the first apple and the probability of picking the second apple, because we're talking about both being what? Apples. So what is this probability of this? Because of this and, we're being told that the probability of picking A1 multiplied by the probability of picking A2. But now, recall with the statement, what is the statement saying? Without replacement. This means A1 and A2 are dependent events. So if they're dependent events, how am I going to write this formula of mine? The probability of A1 will still be the same in the same actual case in terms of the total number and everything. But for the probability of A2, the probability of A2 will be affected. Why? Because we're simply assuming that in the first picking, it was an apple. So the second picking of an apple will be given that the first was also an apple. So this is where the formula is coming from the concept of what? Conditional probabilities. So if this is the case, I'm going to have the probability of this to be what? What is the probability of me picking my first apple? Favorable outcome. How many total number of apples do I have? I have 20 apples. Out of how many fruits do I have? I have 25 fruits. This is how we find the probability. Favorable outcomes over the total number of outcomes. The same is happening now on A2, given that A1 has occurred already. So this time around I want to pick an apple, given that in the first picking it was an apple which was picked. So the probability has been affected in this case. So it means that the probability of me picking an A2 will now be equivalent to be 19. Why 19? Because in the first place I picked an apple. So the number of total apples has decreased by 1. Same as the total number of fruits. It was also decreased by what? 1. So hence having the probability in this case to be 20 over 25 multiplied by 19 over 24. So you can also be, or I mean you can be able to multiply the values there so that you're able to come up with the probability of us picking an apple in the first place and an apple in the second place. So this is just multiplication principle. You can multiply 20 by that and 25 by that. Divide, you can either have it in a fraction form or in a decimal form. It is still the same thing. So we look at the second one as well. We look at the next one. So using my calculator, I'm having something like 0.633 in decimal number when you multiply those two divided by the oasis. Okay, so we have another type of probability basic, where we are using basic rules in probability question. So we have to use all the basic rules which we've learned so far. basically from the additional principle, the complement rule, the multiplication rule, as well as the conditional rule, which we've done so far. We have to apply them here. So you have to first be able to tell, so okay, this is the complement rule, this is the addition rule, this is the multiplication rule, and this is the conditional rule which I'm going to use there. So what is the question saying? We are being told that a random sample of 350 third year biostatistics students majoring in entomology, biodiversity, or microbiology at a university is selected. So this is a random sample selected from 350 third year students. How many courses are we trying to look at? So these 350 students, it's either if I pick a person, this person can be majoring in entomology, this person can be majoring in biodiversity, or this person can be majoring in microbiology. So these are the three programs for these 350 students. And then what are we being told? These students are asked whether or not they are happy with their majors. So basically, maybe I'm doing a certain research to say, okay, we're talking about in the scope of, I'm sure this is called mathematics, where entomology, biodiversity, and microbiology are found. So I'm going to be inspecting each and every student who is going to be picked at random to say, oh, you're doing which program? Entomology. Are you happy with your program or not? So these are the responses which were summarized in the given table below. So we have been told that the first column here represents for the response from the entomology group, the response for the biodiversity group, and the last column there represents the response for the microbiology group. So are you happy or unhappy? That's a table given to us. So from this information, we are being told to say, can you find the probability, the following probability? The first one, we're being told, can you find the probability, which is P, in brackets we have U complement. So entomology is being presented by E, my biodiversity is being presented by B, microbiology is being presented by M. Those who are unhappy, it's being presented by H. Those unhappy being presented by AU. So once you read the question, you're supposed to be able to tell, say, what am I finding? Which rule am I supposed to be able to embrace? Is it the complementary rule? Is it the multiplication rule? Is it the additional rule? Is it the conditional probability rule? Be able to look at which rule are you supposed to bring in or involve in. So number one, if you look at this, something need to click within you. This is a complement. So to those who are even faster, if you are brilliant, like those people who are brilliant, you could have paused the video and solve them out, then later on compare the solutions. So we are starting with the first guy, the probability of U prime. In this case, it is the complement of U. So where am I going to find this? I'm looking at the probability of those who are, if I'm talking about the complement of unhappy, I'm sure this is just the same as saying the probability of happy. So if someone is not happy, is unhappy, automatically someone should be what? I mean, if someone is not, the complement of unhappy should be happy. So complement is more like the opposite of something. So if this person can either be happy or unhappy. So I'm sure we're able to relate in those cases. So if I'm talking about the probability of U complement, what is U? U is unhappy. So it means that I'm talking about the probability of not being in this row. What is the probability of not being in this row? So if you are not in this row, obviously you are supposed to be in the row for the happy part. So where am I getting this principle from? I'm getting this principle from the complement rule. So you can either solve the probability of finding the happy, or you can use the complement rule by just simply saying that probability of u complement is basically 1 minus probability of u. So 1 minus probability of u will give me probability of u complement, coming from the what? The complement rule. So the task here now is to find what is the probability of this u. So this would be 1 minus probability of u. Probability of u will be addition of the 20, 35, and 15 divided by the total students, who are how many? 350. So we're talking about 20 plus 35 plus 15 over 350 students. So we find the total for this, and then the answer we subtract from 1. That is the probability of the students, or the probability of the complement of the unhappy students. If you do not want to do this, you can simply just find, this is the same as saying just find the probability of H. And what is the probability of H? Probability of H is just basically addition of the whole happy students divided by the total, which is 80 plus 115 plus 85 over 350. So it is either you do this or you do this, you'll be able to find this guy. Okay? Yeah. So this question is because I'm not going to completely solve the final answer. I want you to send me the final solution as proof that you've gone through my video. So as proof that you've gone through my video, send me the final solution of the probability of u complement. So in both cases, the first case where I'm simply saying 1 minus probability of u, and the other case where I'm simply saying probability of h equal to that. So send me both, so this is indeed the same value. So now we look at the second one. We are looking at the second one. So send me the solution for this one. So I've given you the outline or the outcome, how you're supposed to go about it. We're using the complement rule. So send me the final solution. After you subtract 1 minus the probability of u, what is the solution? Or if you do not want to use this case, find the probability of those who are happy. Because if you are talking about the complement of unhappy, is basically those people who are what? Who are happy. So I simply say you can either solve it like this, or you can either solve it finding the happy people. So both cases are okay. So this can only be achieved by once you understand the complement rule. We are simply saying that if the event of the other not happening, it is just, if we are simply talking about the probability of A not happening, it is just basically the probability of 1 minus probability of A happening. This is why the complement rule is coming about. I'm sure you watched the previous video under the complement rule. So now looking at the second one. The second one says, what is the probability of B given H? I'm sure we're now familiar with these symbols. So if I write probability P B slash H, this means probability of B given H. So given this formula, we're talking about what kind of rule? We're talking about the conditional probability. This is the conditional rule. So this conditional rule states that probability of B given H is just basically probability of B intersecting with H over probability of H. So we're looking at for the probability of B given that H. So in other terms, what I'm simply saying, what is the probability that a person picked at random is about diversity measure given that that same person is happy? So now, if this person is picked from biodiversity, there can be a possibility that this person can either be what? Unhappy or happy. So what is the probability that if this person is picked at random, this person will be happy? This is what we're looking for. So where I'm going to get this, I'm getting it from the conditional rule, where we're simply saying that B intersection H over probability of H. So what is B intersection H? B intersection H, it is the 115 in this case. These people are the ones from the biodiversity, at the same time are the ones who are simply saying that they are happy. So this information says, remember, this is a probability. So what am I saying? I'm looking for the probability of the intersection, which is 115 over the total, which is 350. This line means division, meaning that I'm dividing by the probability of H. What is the probability of H? The probability of H is 80 plus this plus that divided by 350. So this is 80 plus 115 plus 85 divided by what? 350. Okay? So now, remember, these are fractions. When you simplify this, what are you going to end up with? The 350 will come on top and this will come below, where the 350 and the 50 will cancel. What am I simply saying? I'm going to have something like 115 over 350. This division changes to multiplication of 350 over the addition of this, which is 80 plus 115 plus 85, where this 350 and this 50 goes. So what am I going to have? I'm just going to have a fraction of 115 over the summation of these three. We are okay? So we're looking at the probability of B given H. The probability of B given H. This is just as good as you looking at what is the intersection, the number intersecting biodiversity and happy divided by the total happy in either case. If you do not want to do that, find the probability of the intersection 115 divided by 350. The answer divided the probability of the happy, which is 80, 115, 85 divided by 350. So 115 over 350, which is the intersection. The summation of these three divided by 350, which is the happy. So this is the happy, this is the intersection. So with that, if I am able to do that, I'm able to find the probability of B given H. I also want a solution for this one. I've given an outline on how you're supposed to be able to find that. We're okay? The same is happening on the third part. Remember, use all the rules you know. In this case, we made all the rules from the additional principle until the conditional rule. So what is the third expression telling us? We're being told, say, find the probability of E union H. The union symbolizes what kind of principle or what kind of rule? This one is the additional rule. So if this is the additional rule, the same is happening with this one. This is also a union. M union U is also the additional rule. So how do I find this? Remember, according to the additional principle, finding this, it is just as good as probability of E plus probability of H minus probability of E intersection H. What is the probability of E? Probability of E is basically 80 plus 20 divided by the total, which is 350. What is the probability of H? Probability of H is basically 80 plus 115 plus 85 divided by 350. What is the probability of the intersection? The intersection is basically 80 over the total, which is 350. So once you do this, the mathematics there, you're supposed to be able to find the probability of E union H. The same is with the probability of M union U. M union U, meaning probability of M plus probability of U minus the probability of the intersection. So send me the final solution as well for that one. So if you look at this question, it has embraced a number of rules where we're talking about the complement rule, the additional rule, and the conditional rule, which has also been embraced in this case. So we'll end here and be able to look out in the next video where we're talking about now the bias theorem, where in the bias theorem we're just talking about an extension of the conditional probability. So that's more like grabbing or just adding some sort of spices on the conditional probability rule. That's the bias theorem. Thank you.